Okay, let's take this scenario and work it into a problem with a spreadsheet so we can do the math and get a little spreadsheet work in here. Remember the problem: excellent, good, poor, crash, probability of state, return given the state. And so we just turned it into a spreadsheet that makes it easy for us to play with the numbers. And of course, we want to create a model. That is the idea, is to create a model. So we want to put formulas into the spreadsheet to where we can change them and see different scenarios. So I've obviously just typed in the good, excellent, poor, crash. I typed in the probabilities as 25%. As you can see, I've got them here at the top. And so on, and of course they add up to 1. So I put the sum of C5 to C8, which is these, and I put the sum in there so I would remind myself this always has to equal 1. So as I start messing with it, if this changes, I'll notice it and be a problem. And I could actually put a limit on there and make sure it does, but I'm not going to bother at this point. The return given the state, 31%, 14%, so on. So this is the data that came in. Now we want to calculate things. So again, if you've taken my classes before, you know that I want to put my data up top, and then I'll do my calculations at the bottom. Data up top, calculations at the bottom. That's the way you create a model. That way you know if you change your input, your output should change. This should all be automatically changing. So here's how we did this. The expected return, as you know, is C5 times D5, which in this case is the probability times the state. So C5 times D5 plus D6 times C6. So you can see the formula up here, and you can see that it's very easy to set this up once this is done. Now, I didn't have to put parentheses around each one of these. Why is that? Well, of course, we're going to do the multiplication first and then the addition, because the Excel spreadsheet is set up to do the proper process of operations, so we didn't have to put parentheses around everything, but you need to make sure of that. A very common mistake is because you put a formula in there but you forget the parentheses, or you put the wrong parentheses in. Very common mistakes in setting up models. Okay, we hit the escape key to get back out of that, and I've highlighted this as blue. How do we do that? We go up to the letter key and we highlight it to blue. The reason I did that, we're going to hit escape again. The reason I did this is because this is the answer that comes from all this. So the expected return that I show here, this is the answer. Now, what have I done? I've also copied it here. Now, I just said this is equal to C12. I don't want to recalculate it. There's no reason to recalculate it. I just simply said this is equal to that. And then this is equal to the one above it, and then this is equal to the one above it. So the easy way to do that is, if I had this formula here and these weren't there, I'm just going to wipe these out and just hit delete. The easy way to do that is to simply go equals this, enter, and now once that's there, I just grab this and drag it down, and there it is. And this is equal to C13, this is equal to C14, and all these will change automatically if this number changes. In addition to that, we have to do this other formula, which is eventually we want to get to this, which is the probability of state minus the return of the state minus the expected return squared. So in doing so, I broke it into two different pieces. You could have done it all in one. I just broke it into two. So if you click on this, you can see that what I'm essentially doing is taking the D5, which is up here. I'll move this over so you can see the rows. In fact, I can just delete that row because I'm not using it. There you go. So now you can see that this column, this cell, excuse me, is C5. The blue is nice. It's easy to see which one it is, 31%. And then minus B12, which is the expected return raised to the second power, is part of the equation. And then we take it over here, and this is this part of the equation multiplied by the probability. So I just broke the equation into two pieces. You don't have to do it that way, but you could. It's just a simple, I broke it this way so you could see the steps. So here we go. We have expected return, and we have our standard deviation per each one. And of course, we have to come up with the sum. So how did I do that? I summed them. That's no big deal. Easily sum and just window that in. And then, of course, the variance is the standard deviation is the square root of the variance. And so we just did this. And now the interesting thing here is to do square root. I just wrote, I have it raised to the 0.5 power, which is the square root. Squaring it would be, to the second power. The square root is the inverse of that, which is 0.5. So that's the way I did that in the spreadsheet to get the standard deviation and get the square root in there. You could have done it many different ways. That was the way I particularly done it here. I've also done this in blue, so I know that this is the expected return and this is standard deviation for this scenario. Now, and the blue just allows me to easily see it. That's the only reason I did it in blue. Now, here's the model part. I don't know this probability is excellent. This probability, excellent. What's the excellent economy? I don't think it's 25%. I think it's 20%. Well, now I have an extra 5% to play with here. So I think there's a higher percentage chance of a crash. So I'm going to put 10% in there. Now all my probabilities are different. I still have my states. I haven't messed with them. But look at what difference it is. Now my expected return is only 5.6% and my standard deviation is higher. So I'm going to have more bouncing around and lower expected return because I don't think the economy is as good as you do. And I think there's a higher percentage of a crash. Now, having said that, I can also play with it another way. Excellent, 31%. Well, 31%, excellent, I don't know. So if we go back to historical norms, right? So excellent would be like 2 standard deviations. So 2, in my opinion, this is just an opinion, 2 standard deviations. If the historical mean is 10% and the historical standard deviation is 20%, 2 standard deviations would be 40% on top of the 10%. So I'm going to change this state up here to 51%. And then here at the crash, I'm going to equally take it down. So it's 10%, 2 standard deviations down off 10%. If each standard deviation is 20%, that's 40% off 10%. So this is only 30%. Negative 30%. Negative 30%. Okay, so now this fits more along the scenarios that I'm thinking of. So 50%, in fact, this would actually just be 50%. And so we have 50%, 30%. We looked at the historic norms. We adjusted and so on. Now what do we have? Well, we have a higher expected return because the crash won't be so bad. And, of course, a little bit higher standard deviation because there's a little more volatility going on in the situation because of higher highs and lower, not lower lows, but low lows too. So there's more volatility going on. So you can play with this any way you want. What you're essentially doing is becoming an investment manager that's looking at the overall macro economy. So the question is, what is your probability for good, excellent, poor, crash? In addition to that, you don't have to do 4 here. You can only do 3, or you could do 6. You could say good, excellent, mediocre, maybe crash, and then you could say nightmare. So you could have a nightmare scenario in here. So if I change crash to nightmare scenario, and I say the probability of it is, let's say, 0.02, which is 2%. And then I have 92%, so I have 8% here to mess with. And let's say the poor, now let's add it to excellent. So this is now 28%. So we've got our 1 here, so we're okay. But the crash here, let's take it significantly down. Let's go down and say the crash is, instead of 30% down, let's say the crash is 6 standard deviations to the mean. 6 standard deviations to the mean. 6 standard deviations to the mean. That's 6 sigma, right? So if the mean is 10% and 6 times 20 is 120%, it's going to basically go to almost 0. So that's not going to happen. Let's take it up a little bit from there and say we're going to lose 80% of our money. And in fact, in the Depression, the stock market was down 60, 70%, I forget, but it was very, very high. So let's just say there's a 2% chance of a nuclear event, a terrorist thing. And so let's put that in there. And so what happens here? Our expected return, because we have very high probability of an excellent economy with a 50% return, is 17%. and our standard deviation is 25%. So it's more volatile than we would expect. But our crash scenario here, the one we're worried about, doesn't have a very high percentage of probability, but it's there. So what keeps investment managers up at night isn't trying to get just these numbers right. It's trying to figure out if this scenario will happen. So you can see how you can play with the numbers. You can see that your expected return should be good. Your standard deviation is not too bad. You're okay with all of that. And there's still the chance that we will have a housing crisis and send housing down 40% and everybody's in trouble. Or there could be a nuclear event or a terrorist event or other things that would create this crash scenario. There's more on that on variance and risk, and you can look at those types of scenarios and play with it. I mean, this is what this course is about, and all the courses are about. Now you have a model. You have a model that you can play with, that you know how it works, and you can judge your own version of the economy. In fact, that's going to be your assignment, obviously. You can put your own return based on the state, either historically or what you think it'll be, and the model will give you an expected return and a standard deviation, and from there you can decide, oh, should I invest, should I not invest? So here you go. You have a model. You have different scenarios you can use your own judgment on, and it should give you a picture of what the future would look like. So play with that, do the homework, and you should be on your way to becoming an investment manager that worries about things like 2% crashes and 80% down, as well as trying to pick probabilities in the given state of return based on all the information, a mosaic of information that is out there.